Machine learning and data science these days are just majorly dependent on NumPy for linear algebra or just arrays in general. Hence, this video will show you the top 10 functions of NumPy that you must know for machine learning and data science. Let's get started. So the first function is going to be reshape. Now generally in machine learning, before providing the data to the model itself, you will have to ensure that the given data is in the format of a two-dimensional array. And most often than not, you would end up with a series or a sequence object such as a list or a tuple. So to illustrate this, first I will create a random list of values and we will have to convert this to a two-dimensional array before providing this to the model. So what we do is first convert this to a NumPy array. I'm just going to call this arr np.array and then pass in the list. Now our list is converted into an array, and now we can use the array.reshape function to make this into a two-dimensional vector which contains 3 rows and 2 columns for my case. Now when you run this code, we see an array which contains 3 rows and 2 columns. Here the rows are considered as records and the number of columns is considered as features, which will bring us on to our next set of functions, which will be related to normalization in machine learning. Let's take the example of a housing price prediction, and let's say our training set has 2 features. One being the size of the house in square feet. This might range from 0 to 5,000. And then the second feature, that is the number of bedrooms, and this will range from 0 to 5. Now we see the range difference between these 2 features is just drastically high. It's only optimal if we have a similar range for both, and that range should be a small number, like maybe 0 to 1 or -1 to 1. The method used for doing this is called normalization. Now we are not going to go too deep into this, but I will show you some popular functions that plays a part while performing these normalizations. So first, let's create a random initial array, and the first function that I will show you is the mean function to calculate the mean. And using this, we perform the z-score normalization. To calculate the mean, you just type in np.mean and then pass in the given array. This will return the mean of the given array. Followed by, you can also calculate the standard deviation of a given array. This is used for z-score normalization. And to calculate standard deviation, you just type in np.std, pass in the given array, like that. You get the standard deviation. And one more main function that I wish to mention is the L2 norm. This in math is referred to as calculating the magnitude of a given vector, and this is used for performing L2 normalization. In order to do this, we just type in np and then use a subset inside the NumPy module itself, which is known as linear algebra, and then inside this you type in norm. You pass in the given array, you get the magnitude of the given vector, like that. Now the next set of given functions that I'm going to show you is used for multiple vector calculations. This involves manipulation of 2 vectors or 3 vectors together. So let's first again create 4 initial arrays. Here we have 4 arrays, the array 1 and the array 2 being one-dimensional, and the next 2 arrays are square matrices of the size 2. So the first thing that you could do is calculate the dot product, and in order to calculate the dot product, you just type in np.dot and then pass in the 2 arrays. Array 1, array 2, like that. This will return the dot product of the first 2 arrays. You see that the value is 32. You can also perform matrix multiplication for the other 2 vectors by typing in np.matmul and then pass in the other 2 vectors, a, b. These are the matrices that we created, and they are square matrices over here. So when you run this, you get a square matrices in return, and it contains all the matrix multiplication values. And finally, you can also calculate the inverse and the transpose of a matrix, by typing in np.transpose. You just transpose the matrix, that is converting the rows into columns and vice versa for a given vector. I will just pass in a to show you first. You see that the first row is converted to first column, and similarly for the second row as well. And to calculate inverse, you just type in np.linearalgebra.inverse and then you pass in, let's say, b. You find the inverse of the squared matrix. Now the next set is going to be some additional functions that are used very often in machine learning. So first, as always, let's create a random initial array, and then the first 2 functions that I wish to show you is argmax and argmin. So when you type in np.argmax, this will find the maximum value of the given array and returns that index of that maximum value. So when you run this code, you see that index 2, that is the value 20, is the maximum from the given array. Similarly, when you type in np.argmin and then pass in the array, you see that value 5, that is of the index 1, has the minimum value. Now of this sort, there is another function argsort. When you type in np.argsort and pass in the array, this will sort the given array and then returns the sorted indices. So when you run this code, you will see that 1 being the smallest value, that is 5, and then the index 2, that is 20, has the largest value, and it scales off like that in the ascending order. Now the final set is used to generate or initialize a random initial array. So to initialize a random array. So the first function that I will show you is np.zeros. This will create an array of the given shape, and each and every element inside that array will be 0. So let's type in a.shape, that is the square matrix that we created above. When you run this, you get the square matrix which only contains elements of 0. You can also use np.ones to create an array of the given shape which has all the elements to be 1. This can be used for initial multiplications as well. So why are we doing this? Because when working with large sets of data, or when initializing an array for some learning algorithms, these two functions seems to be pretty useful. Let me just type that below, zeros, and then pass in b.shape. Are you on this? Yeah. So these two functions are really useful in initializing a random arrays and then later manipulating them whenever it's needed.